Hey, Bogdan Brzeski here. Welcome to another video, Quadratic Functions Mastering Skills. In this video, we'll be developing equations given x-intercepts of vertex. Let's dive in. So, quadratic functions can be solved or developed when two x-intercepts are given, or one x-intercepts and vertex, or any three randomly selected points. So, quick reminder, quadratic equation in standard form. A, coefficient is never equal to 0. B, coefficient and C can be equal to 0. And then there is a connection between the quadratic formula that you're familiar with already, how many roots versus how many x-intercepts. So if it's greater than 0, if two roots, two x-intercepts, sometimes when the discriminant is equal to 0, then you have one x-intercept, one root of the quadratic equation. If it's less than 0, no x-intercepts and no roots. However, the vertex can be always obtained by using that formula that you're already familiar with. So let's work with the following example. In this example, I have the following: one x-intercept, which is given in irrational form, which makes the question a little bit more difficult. And the vertex is provided as well. So our objective here is find the other x-intercept and develop the equation in standard form. So we can start with utilizing vertex formula for this question. Why? Because the vertex is given 2 and -4. So immediately you replace h with 2 and k with -4. Oftentimes it is a good idea to create a kind of a sketch of the situation, sort of to visualize the word problem. So now we have one x-intercept, so that means when y is equal to 0, x is equal to 2 plus square root 2. There is a location of the vertex, and by symmetry, the second point that we will find a little bit later can be obtained just because we know that parabolic shape is symmetrical in the axis of symmetry, which always passes through the vertex. So what is the benefit of having the x-intercept provided? We can replace y with 0 and x with 2 plus square root 2 in this case, and then solve this equation for a, because having the a coefficient is necessary for us to claim that we have developed a quadratic function formula. So conveniently 2 and -2 cancel each other out. Square root 2 will be raised to the power of 2, which is 2. So 4 is equal a times 2. Therefore, a is equal to 2. So now we have the leading coefficient established. To find the second, and so this is the quadratic formula in vertex form with the leading coefficient already solved for. To find the second root, we can create, if you remember the symmetry, the average between the first and the second divided by 2. So the first x-intercept, the second is called x, add it, divide by 2, and we know the axis of symmetry or the vertex location is equal to 2. So hence why we say let this be equal to 2, and then cross multiply, make it 4, move 2 plus root 2 on the other side, bingo, you have the second root of that equation. Now, you can also find it by solving it by using quadratic formula. It doesn't really matter the way you solve it, as long as you utilize any of those skills that you already have by learning about quadratics. So the second example, before we go to there, we have to just quickly summarize what we have. A is equal to 2, we just found it. How do you find coefficient b? You can use the vertex coordinates formula, b or negative b over 2a, replace a with 2, and then solve it for b. And how do you find c from the vertex form? X is equal to 0. Remember, c represents the y-intercept, so x is 0. Put it 0 for x right here would give you the value of c is equal to 4. And then changing vertex in the standard form is about working with perfect square trinomial, or being able to expand binomial to the power of 2. So this is done by doing the following steps. Keep the leading coefficient, expand inside. So x minus 2 times x minus 2. You can do the long way, the FOIL method. It doesn't matter how you do it. Or you can directly apply the perfect square trinomial formula. So you square the first, you know you're going to square the last term, and the middle is 2 times first times second. So this is negative 4x. Then multiply everything times 2. When you distribute, remember, you understand the rules in algebra. So you have 2x squared minus 8x plus 8 minus 4 will give you 4 in the end. So therefore, boom, we have the questions completed. Not complicated, even though the first intercept was given as irrational function. Okay, so the next example has 2 x-intercepts in irrational form. That makes the question a little bit more difficult. And a random point. So this is not the vertex. So I have 3 points. So you could think of creating 3 equations as we did in the other video. Or if you utilize the factored form, you can benefit from that as well. So let's use that form, because this is probably the quickest way of getting what we want. So determine the equation in standard form. We'll do that later, but we have to have A figured out. So that's the first item on the list. Now, substituting the root x minus p, if you remember the formula, times x minus q. And we have to observe the pattern here, because you can do a lot of steps, but sometimes those random steps may not give you the results that you anticipated. Now, x is equal to negative 2, so we will replace x with negative 2 in this bracket and in this bracket. When x is equal to negative 2, this is the given point, y is equal to 4. So this is why you see this equation where left side is equal to 4. And then you have negative 2 minus 3 in brackets plus square root 2. Multiply by negative 2 minus 3 minus square root 2. So this is the good time, instead of multiplying separately all those 3 by 3 to create 9 terms, long way to go. Quickly observe the pattern. Negative 2 and negative 3 can be combined into one number, negative 5, for both brackets, right? So we will collect like terms. Before you expand, always make sure that you have collected like terms so you can simplify the expression. Now we have negative 5 plus root 2 and negative 5 minus root 2, which reminds you, hopefully, if not, you can quickly recall the the difference of squares application. A plus b times a minus b is equal to a squared minus b squared. Yes, you can do the FOIL, as I said, and expand it, or you can take advantage of that difference of squares formula. So this is why you have negative 5 squared minus square root 2 raised to the power of 2. So the left side is 4, you keep it. The leading coefficient a is something that we're looking for, and now we raise this to the power of 2, so this is positive 25 minus 2 inside of the bracket, and boom, 23 is the answer. So the long bracket, after we did all the work, is simplified to 23. The left side is 4, You're finding how much is A. You must divide it both sides by 23. Boom. We have the leading coefficient as A fractions. We're not going to change to a decimal because this would not be exact. We cannot simplify it further. We keep it. So now we go back to that factored form expression for the quadratic formula. We have the leading coefficient. We have x minus p times x minus q. If you remember the factored form, so root 1, if you distribute, you have negative 3 plus root 2, negative 3 minus root 2. When you do the proper distribution of that root, because remember, each root is an entity that consists of two terms, unlike terms 3 plus root 2 and 3 minus root 2. When you do the distribution of negative sign, you have minus 3 plus and minus 3 minus. So hopefully that makes sense where this comes from. And again, observe that we working here with multiplication of polynomials. We cannot do the long way, although we could, but this is counterproductive. So x minus 3 and x minus 3 is the same term. So if you make the analogy with difference of squares in factored form, you have a squared minus b squared, because you have a plus b times, again, a minus b. So take advantage and show it that this is, in brackets, a squared minus b squared. Square root 2 can be raised to the power of 2. You can quickly do the binomial squared as a perfect square trinomial. So you get x squared minus 6x plus 9 minus 2. See, when you observe patterns, things in algebra are not as difficult as you may perceive them in the first place. So collecting like terms, it will give you x squared minus 6x plus 7. And then you multiply by the outside term 4 over 23. So this is the first coefficient A, the coefficient B, and coefficient C. Voila, you have the question done. Fast and simple when you observe which method is the most useful, difference of squares. When you recall the standard form, factored form, and vertex form, when you have this equations down pat, you know which one is the best useful for a particular application, and then you can solve the questions fairly easy. Practice is always necessary when consolidating learning. Thanks for watching. We'll see you again with another video. Don't forget to share it and ask questions down below. Bye for now.